Hi, let's talk about the last concept of this module, which is the concept of astronomical time. There is one concept of time that we have already discussed, which is the sidereal time. So the sidereal time is the hour angle of the vernal equinox. Notice that by the definition of right ascension, then the local sidereal time is also the right ascension that is on the meridian. It's the angle from the vernal point to where you're measuring. So the right ascension of the meridian is the local sidereal time. We can define based on that the longitude. Determining the longitude on the surface of the Earth was a long-standing problem in the history of science. Because one day is 24 hours long, one can use the time to calculate the longitude. So 1 hour of time difference corresponds to 15 degrees of longitude, right? You get 360 degrees divided by 24 hours, you have 15 degrees per hour. So suppose that you have an observer that sets their clock to 12 p.m. and noon on Greenwich, the prime meridian, and then travels a long distance. The observer will then notice that the sun is highest in the sky at 4 p.m. according to the clock. Then the observer knows that at their longitude is 60 degrees west, because it's 4 hours times 15 degrees per hour is equal to 60 degrees. So longitude is time. We have here in this diagram, this angle being the Greenwich hour angle and the local hour angle, right? You have the sun in here. So this is the 0 hour angle. This is the hour angle measured at Greenwich. And this is the hour angle measured at your local longitude. The longitude is the difference between the Greenwich hour angle and the local hour angle. If you have the time at Greenwich and you have the local time, you can determine your longitude. In fact, throughout the 19th century, ships had several clocks synchronized with the Greenwich time so that they could know what their longitude was. In general, one does not need the sun and moon. Any star will do at any hour angle. From the geometry of this figure, you can see here. So this is the Greenwich meridian. This is where the observer is. This is a random star. You have the local hour angle of the star, the hour angle measured at Greenwich. The longitude of the observer is the local time, which is this angle, minus the Greenwich time, which is this angle here. Now we can also define the sidereal and the solar time. Now the sidereal time is the hour angle of the vernal equinox. Based on this, we can define the sidereal day, which is the time interval between two successive culminations of the vernal point. So as you see here, this red dot is an observer on the surface of the Earth. When the Earth returns to the same position with respect to the distant stars, that means when you have two combinations of the same star, say the vernal point, you have a sidereal day. Now the solar time, the solar day, is defined with respect to the sun. It's two successive combinations of the sun. As you can see from this figure, if you follow here the red point of the observer, this is the end of the sidereal day when the Earth is pointed to the same star. And here's the end of the solar day when the sun is back at culmination. As you see, the Earth has to turn a little bit more, about 1 degree more, between a sidereal day and a solar day. In fact, the solar day is about 4 minutes longer, 3 minutes and 56 seconds longer than the sidereal day. So this is another way of seeing it. A sidereal day is when the orientation of the Earth is the same with respect to a distant star. So it would be the time interval between this point and this point. Whereas a solar day is when the Earth is with the same orientation with respect to the sun. So it's the time interval between this situation and this situation here, when the same observer on the surface of the Earth is seeing the sun on the zenith.